my name is Karen. I'm a chemical engineer at the Energy and Bioengineering Group. And I've been working mostly in the educational project, which is how can we reach students at elementary school level to get them involved in climate change and in the Solar Biocells project. So we all know algae and from the algae blooms in the spring, right? And we know that they are aquatic organisms that grow in ponds, or in our case in photobioreactors. And as any other plant, they require carbon dioxide to grow. Thing is that current systems, they use neutral conditions, so that means pH close to 7. And at these conditions, carbon dioxide does not dissolve that well. So what happens is that if you have 1 liter of this neutral pH medium, you will probably absorb less the amount contained in 1 liter of air. So what current system does is that they bubble a very concentrated stream of CO2 into the system. So bubbling, which looks pretty much like a jacuzzi, will end up being a very energy-intensive operation and therefore very expensive. So if your main idea is to produce biofuels or any source of energy from this algae production, if you're bubbling carbon dioxide into the system, you will be probably using a significant amount of the energy produced into just bubbling the carbon dioxide. So what we are proposing here at Solar Biocells is the use of a highly concentrated solution at high alkalinity and high pH. At these conditions, we will have a significant concentration of carbonates in the liquid phase, which means that when these carbonates get in contact with the carbon dioxide in the air and the water in the solution, they generate a chemical reaction that transforms that into bicarbonate. And this high concentration of bicarbonate, or this change in concentration in the solution, during this chemical reaction, the pH changes in the solution, in our case from 10.5 to 9. And because of this, our medium is able to absorb significant amounts of carbon dioxide in the form of bicarbonate. So if you take 1 liter of this high alkalinity and high pH solution, you will end up absorbing around 20,000 times the one you will get with neutral pH. Once the carbon dioxide is absorbed by our algae, it is transformed again into carbon dioxide in the liquid phase, and it's used for regular growth. As our medium contains that much amount of carbon dioxide in the form of carbonates and bicarbonates, we don't need to bubble the carbon dioxide into the liquid solution, saving energy and money. But we still need to provide that carbon dioxide from the air to the system. This supply of carbon dioxide from the air happens in a separate unit. This separate unit would require less than 10% of the energy required just to bubbling the carbon dioxide into the system, making the entire process more sustainable and less energy intensive. Thank you very much for watching, and don't forget to subscribe and follow us in our social media.